Hello, this is Ms. DB. In this video, we are going to graph sine and cosine functions. So this is kind of a fun thing to do, to look at some more functions. Functions, remember, are those like quadratic functions and cubic functions and square root functions. We've looked at lots and lots of functions this year. So we want to end up with looking at sine and cosine. Now we worked on the unit circle, and the values from the unit circle, the y values, which were the sine values, can be put on a coordinate system and mapped so that you get the sine curve. The only thing is our x-axis is, instead of being 1, 2, 3, 4, 5 like we're used to seeing, we're going to put the radian values on here. So pi is at approximately 3.14, and 2 pi is at approximately 6.28. So you can calculate those values and put them in Desmos, just puts the numbers on here instead of pi. If you use Sketchpad, you'll see that you can actually get these pi values to show up. And these are the y values that go along with what x is equal to. So again, these are the radian measures of the angle on the unit circle. All right, so, and there's a demo in your you can see how this traces out. There's a video in your folder that you can watch. All right, so here's lots of vocab in this section. Periodic functions are functions that repeat in regular intervals, called cycles. So here the sine curve is periodic because it goes to there, and then it would repeat, and it would keep going forever and ever and ever in both directions. So that's a periodic function. And the length of a cycle is called its period. So the period is from where before it starts repeating. So let's look at this example. For 1, 2, and 3, you just have to say what the period is. So this one starts at -2, and then it goes down through -1, and then back up to 0. And then it starts over. So when it starts over is when you stop to count the period. This period goes from -2 to 0. It's 2 units long. Or you can look at it on this side. Let's see. Goes up, down to 1, then back up to 2. Yep, it's 2 units long. So the period of this one is 2. This has the sine and cosine function on here, so you can find their period. So you can start counting here, or maybe you want to start at 0, 0 to make it a little easier. You can see that it goes up, comes back down, then it goes down below the x-axis and back here. Where it starts to start over from, let me draw this, one period would be from here to here. And we can see that that goes from 0 to 2 pi. So the period of the sine function is 2 pi. And you can do the same thing for the cosine function. Start counting at the beginning of its cycle, maybe right here, and then go down and up to right here. So here we've got from here to here is pi over 2. And then from here to here is 3 pi over 2. So you can add those together. Even easier would be if we started our counting from here, and then it goes down, up, and when it gets back to that same point, you can see what the period is. All right, another word that we're going to learn is amplitude. The amplitude is how high it reaches from the x-axis. So from here to here, that's its amplitude. You can find the amplitude by taking the maximum minus the minimum and dividing it by 2. Or you can look at the graph and say, okay, it's from the x-axis to its lowest point, that's the amplitude, or from the x-axis to the highest point, that's its amplitude. The amplitude for y equals sine x, the sine curve, is 1. The amplitude of the cosine curve is also 1. Domain of each of these curves is all real numbers. It will continue to go in both directions. There's nothing that x cannot be, so it's all real numbers. The range of the parent function of sine, the highest it ever gets is +1, and the lowest it ever gets is -1. So y is between -1 and 1, including those values. If it has been transformed, then the range will vary. So make sure that you don't always answer this. The range will vary. The domain will always be all real numbers unless it's limited by a real-world situation. Like if x is time, then maybe time can only be positive in most cases. And then what else do we need to know? The domain and range we talked about. We talked about the period already. I think we got all of those. So the amplitude and period can change when the sine and cosine functions are stretched or compressed. And that's what we're going to look at more in this worksheet. So if you multiply by a number greater than 1, then it's a vertical stretch. If you multiply the function by a fraction between 0 and 1, then it's a vertical compression. That will change its amplitude. So it'll either go higher on each period, or it will be more compressed and not go as high. Those are the two things that can happen by multiplying by some value of a. We can also multiply just the x by a number, and that will be a horizontal stretch or compression. So that will change how it looks as well. And as usual, the vertical transformation is easier to figure out. The amplitude will just be whatever that number is, the absolute value of that number. And the period will be changed if you change the horizontal stretch or compression, if you change b. So the period will be bigger or smaller if you do that. And the way you find it is, since normally sine and cosine are 2 pi, we divide by that value, just the absolute value of that number. And multiplying by a negative a will reflect it over the x-axis. Changing the x value by a negative number would do something different, but we'll look at just if a is negative, it'll reflect over the x-axis. So it'll be upside down, kind of. Here's an example. We are going to graph 3 times the sine of 2x. So we're going to do these steps here to help us do that. First of all, we're going to graph just the regular sine of x first, the parent function, and that's in blue here. That's the sine curve. Now we're going to identify the amplitude and the period. So the amplitude is what we're multiplying the whole function by, and in this one that would be 3. So the amplitude is 3. And if it was a negative, we would still say the amplitude was 3 because we take the absolute value of it. If it's negative, it reflects it over the x-axis, which flips it upside down as well. B, that's what we're multiplying the x term by, and in this case that's 2. So we actually would go 1/2. If you had to say how it was being transformed, you would say it's compressed by 1/2. But what we really need to know is what is the period, and the period is 2 pi divided by 2. And those 2's cancel, so our period is going to be pi instead of 2 pi. So there's our period. Now we're going to graph this. Well, we know the amplitude is 3 instead of 1, so it's going to go all the way up to 3 and -3. And the period is pi, so it's going to complete one cycle faster, twice as fast as the sine curve does. And since it's already graphed, it's a little hard to show you that, but we can also get the minimum and maximum value from the amplitude. We know it'll be 3 and -3 instead of 1 and -1. And the domain would be all real numbers, and the range would be that y would be between 3 and -3, including those points. All right, so let's go on to number 4. So on number 4, we are going to do exactly what we just said with the problem to do for you. So we are going to graph 0.5 cosine of 2x, and the graph of cosine of x is already here to help us out with that. So we'll graph this one by hand, and then we'll look at Desmos, how we can do this in Desmos. So find the amplitude. Well, the amplitude is just what we are multiplying the whole function by. So the amplitude for this one would be 0.5, or you could write that as 1/2. So that means it's going to not go all the way up to 1 and -1. It'll be half of that high. Let's find the period before we go on. X is being multiplied by 2. So this would be 2 pi divided by the absolute value of b. Well, it's still positive. So the period is just pi. That means it's going to complete one cycle. Instead of it taking 2 pi to complete one cycle like cosine usually does, it will get all done by pi. So it's going to go faster. What are the maximum and minimum values? Well, it's not going to go as high. So our maximum value is 0.5, and our minimum value would be -0.5. So here's the graph of cosine of x. We're going to use the same thing, and I'm going to use a pen tool to make this a little bit easier. And I'll use a different color. I'll use red. Okay, let's put some marks on here. I know that it's going to have a maximum minimum of 0.5, so it's only going to vary. It's going to curve back and forth between those dashed red lines I put on here. And what else do we know? We know that the period is pi, so it has to complete a whole cycle from here to here. So our maximum point will be here, and it's going to go faster. So instead of our minimum being at pi, it'll be at pi over 2. And then it's going to be all the way back up to here by pi. And let me put a few more points on here. My next point would be at here and here. So something like that. Let's put another point on here. Oops, that one got off a little bit. It's supposed to already come back down. No, it's supposed to come back down here, so that's okay. Okay, now that obviously is pretty rough to draw. The domain would be all real numbers. And the range would be between 0.5 or 1/2 and negative 0.5. So put the lower one first. Negative 0.5. And that is the y value. And I need to underline that, and I didn't. Let's look at this in Desmos. We want to graph 0.5 cosine of 2x. So you don't have to graph it by hand if you want to graph both of them in Desmos. So here is my Desmos. I first want to graph sine of x. So in Desmos, you just type sine of x. And let's zoom in so we can see that this is going between 1 and negative 1. Now, like I said in Desmos, they don't put pi and negative pi. But pi would be at 3.14. So you can see that pi is right there. And 2 pi is at approximately, I don't know if I can just write 2 pi. I can, but it doesn't graph it for me. I could put a point at 2 pi and 0. Yeah, that's it. There's 2 pi. That's how long the period is for a normal sine curve, the parent, that hasn't been changed. I think, though, that I'm supposed to be doing cosine for this one, aren't I? Let's get back to my, yeah, this is cosine. So instead of cosine, I want sine. It still has a period of 2 pi, though. So here's what it looks like at pi, and then at 2 pi, it gets back up to its peak here. And my function is going to be 2, well, it was 0.5 cosine of 2x. And it gives me lots of critical values that I can look at. So at x equals 0, y is at 0.5. And then at, oh, it even gives it to me in radians. At pi over 4, it's at 0. I'm going to highlight some of these. That's very helpful. Oops, they went away. We'll get some of these on here so we can see if ours looks that way when we graph it. And then I am going to take a screenshot of this, and I can paste it into the graph. So I'm using a tool in Windows called Snip and Sketch to get a screenshot. And now I'm going to go back to the worksheet. And remember, you can also use a link if you prefer. So my graph, I'm going to put down here, is a little bit off of the way it should have been. So this is, over here is the x-axis, and then it curves from there. Okay, so you're going to do the same thing for 5 and 6. You can try graphing them by hand, and then, or you can use Desmos to get a graph made for you, or you can do both, like I just did, and kind of check how it works. In this one, the amplitude will be bigger, so it's, and let's see, what will the period be doing? I think the period is slower because it's 1/2. And let me just help you out with b. The period is going to be 2 pi divided by the absolute value of b, and b is 1/2. You can multiply top and bottom by 2, and you will get 4 pi on top divided by 1. So the period is 4 pi, which means it's going to be twice as long to get one period completed. And number 6 is going to be a really fast, going up and down one. All right, number 7, 8, and 9 is just to describe how these functions will be different than the parent function. So what's changed? What's changed to the amplitude? What's changed to the period? You can say that. And number 1 of these is a reflection too, so make sure you get that. And then there's a couple that are graphed for you, and you need to say what is the period, what is the amplitude, and see if you can figure out the equation. The equations will be similar to what we have done. There will be, all of them will have some, like this. There will be some number multiplied by the whole function, that changes its amplitude, and the b changes its period. So do the best you can on those equations. And you can check those equations by graphing it in technology. Sketchpad is good, or Desmos, or graphing calculator, and see if your equation matches what this graph looks like. There's only a couple of those to try out, and you can do your best. All right, I hope you have a wonderful day. Thank you very much.